The remainder theorem allows us to figure out the remainder of a polynomial division without having to actually divide, which is nice. If we are dividing by an expression in the form of x minus c, all we need to do is plug in c to the function, to the polynomial function, and the answer that we get will be the remainder if we were to have done either long division or synthetic division. Now, the factor theorem allows us to tell if x minus c is a factor, because if we plug in c and out comes 0, that means our remainder is 0, which means that x minus c divides evenly into that polynomial, and therefore it is a factor. Okay, so let's do a couple of examples. You'll see down here I have a polynomial, f of x and g of x, and I want to first find the remainder if I were to divide by x minus 7, and then determine if g of x is a factor of f of x, or does it divide evenly into it. We're going to use our calculator to kind of help us here. So I'm going to go to just my normal home page, and I am going to plug in positive 7. So I'm going to take f and I'm going to plug in 7 into it and see what I get when I clean that up. So here we go. So we're going to say 7 raised to the 4th power. Well, let's clear that out. 7 to the 4th minus 6 times 7 cubed minus 40 times 7 plus 33. And you'll see that our answer is 96. So when we plug in 7, our answer is 96. That means that this is the remainder. Now let's ask the question, is x minus 7 a factor of x to the 4th minus 6x cubed minus 40x plus 33? And we can say not a factor. Okay, let's try another one. All right, here is negative 10x to the 5th plus 3x minus 7, and we're going to divide that by x plus 1, and we want to know what the remainder would be. So we're going to take f and we're going to plug in negative 1, and we're going to see what we get. Okay, so let's clear this out. So negative 10, wherever there's an x, I'm going to put a negative 1, raise that to the 5th, plus 3 times negative 1, minus 7. And look at that, we get 0. So when we plug in negative 1, we get 0. So we have a remainder of 0. So remainder. Now, is x plus 1 a factor of this polynomial right here? And yes, it is. It is a factor. Is a factor because it divides in evenly and gives us a remainder of 0.